Sweat hour. Um,
Yeah, welcome back. We're here.
we're here.
Uh,
We've been recording now for a while, so we'll see if this sticks.
yeah, but we're going
But
to talk about AC
we're
motors.
going to talk about AC motors come hell or high water.
Yeah,
Um,
very important topic. You guys need to know them. So,
so we're pushing ourselves to the limit to make sure we deliver that to you. So the first little bit here, we're going to kind of just do a general overview of AC motors.
like what and kind of the significance of them, I think, in when it comes to the impact they had on
Industry.
on industry, because it is significant. The advent of the AC motor is like heralds in Industry 2.0, the second industrial revolution.
The second, because the first industrial revolution is what you see over there on the left.
Yeah,
Essentially, that industrial revolution was powered by things like water wheels or giant steam engines.
yeah,
And so like they were centrally located, and then they used mechanical distribution of these shafts that are running along the ceiling, and then they ran belts to individual machines.
yeah. And so like, and what this meant is that like the distribution here was like a bunch of parallel mechanical connections that had to be managed together as a separate
As a separate item here,
Yeah.
and so like to shut one machine down was to shut all of them down.
yeah. And so like it was not a none of the machines were individually powered.
Yeah.
And so from a plant management perspective, this had implications on like the like efficiency, this had implications on maintenance, this had implications on reliability of processes, like all of this stuff came down to that. And so like on the right hand side here, also just like general safety in working in this environment. This is a dangerous type of environment to work
Think
in.
about it like if you were wearing a tie and it got caught in that belt, it'd
Yeah.
be hauling you up to the ceiling by your neck.
Yeah. Or you'd get mulched by this gearing down at the bottom or something like that.
Yeah.
So like,
So there's a whole lot of dangers to this. So what the electrification meant is we just needed to run wires to individual machines. They were powered locally. They were a lot safer as a result of that, and
they ran a lot more efficiently.
they ran a lot more efficiently. And you could shut off individual machines without shutting down the entire plant.
Yeah. And so like when you needed to rearrange portions of the plant, like this is where like Industrial 2.0, a lot of really kind of impactful things happened. This like the electrification of the factory really resulted in essentially like the first like production, like real production lines, what we would consider like a modern production line. Like the Model T is like that production system was enabled by essentially the AC motor.
Yes, absolutely, absolutely. And another thing to kind of like we're getting into the history here. Like people tend to ascribe the second industrial revolution with the industrial revolution here in the states.
In the States, in particular.
because the United States wasn't as big of a part of the first industrial revolution.
That was
Like,
really England and Europe.
England, Europe, Germany,
Yeah.
like those were the first industrialists, and this was things that were happening in the like early 1800s
Yeah.
onward. The second industrial revolution was where the industrial revolution really picked up in the United States, and that's why we kind of think about that
As
when we
our-
think about the industrial revolution.
That tends to like they kind of get like merged together, but they are two kind of distinct events.
Yeah.
And so when we're looking at them, like from we're looking here at like this is a lathe, a type of machine that we use to make round parts, essentially,
And lathes have been around
for a long time.
for a very, very long time. If you've ever met somebody with the name Turner,
They have that name because their job was running a lathe.
I mean, their ancestors, or
Yeah.
their ancestors' job was running a lathe.
That's where the name Turner comes from. Is that it was a job description.
Just like Miller is for
Somebody who,
runs a sawmill,
yeah,
or Sawyer is a sawmill
Yeah.
job as well. So, so you know, with this, you know, the motors that are in this, there are multiple motors that are within this, but the main headstock is spinning based upon this main drive motor
Yeah.
that you see off there to the left.
And you know, this also, like the advent of the AC motor also allowed us to create much more complex machines, more that ran much more more efficiently than other machines. So
Yeah.
we have modern systems today might involve multiple AC motors for running all kinds of stuff on them. So here's another example of a modern piece of equipment that runs off of that can run off of AC motors. We have actually a lot of stuff in here is going to be involved with AC motors potentially.
Yeah.
Conveyor systems, the robot itself, its actual axes and stuff, probably all AC motors.
I mean, they could be DC servos. In
Yeah.
fact, I think on this one, a lot of these are DC servos, but the conveyors are going to be running. The conveyors in the system are going to be running on AC motors,
Yeah.
et cetera, et cetera. So you're going to see various different types.
More conveyance.
More conveyance, yeah, huge there.
This production line, not necessarily the robots that are involved here, but like the mechanism that is moving these car chassis down this production line is probably ultimately driven by AC motors at the end of it.
Just like Henry Ford's original conveyor belt in the assembly line
Yeah.
was as well.
Yeah, like it doesn't, like this concept hasn't really changed since we got the AC motor.
Yeah.
From that perspective. Also, when we're looking at these types of, it's not necessarily here that AC motors are involved directly with this, these machines.
Linear drives.
The linear drives, but the AC motor is kind of instrumental in the infrastructure that supports the development of equipment like this.
And especially something like the power horse behind this.
Yeah.
You know, like these are a lot of pneumatic actuators actually.
Yeah.
And so that means that like there's an AC motor that's driving the compressor for this.
Yeah.
So a lot of the power that comes into this is driven by an AC motor, even if it's not like a motor on an axis. It's driving fluid power.
Yeah, it's driving fluid power, like because a motor is responsible for operating the prime mover of the entire system.
Yeah, I mean, it's very rare to have anything other than an AC motor that's driving either a hydraulic pump or a pneumatic air compressor.
Yeah, yes, like I can't actually think of many modern day applications where that is.
I mean, there's some field construction work where you'll use a gas engine for that, but the vast majority of the time, it's
anything that's in a production facility.
Anything that's like in a building, rather than like jury rigging something out in the field, it's going to run an AC motor.
Yeah, or it's going to be ultimately driven by an AC motor at the end of the day. So that brings us to the different types of AC motors that exist.
Here's a family tree.
Yes. You can see there are a lot of them.
There are many of them. You need to remember, you know...
I think, like, we kind of need to just understand, like, the big categories up at the top here.
Yeah, and, you know, you need to get used to hearing things like a squirrel cage motor, which is a type of induction motor. And we'll kind of see, like we're going to spend a lot of time on the squirrel cage motor.
Yeah, like it's probably the most common AC motor out there.
There are wound rotor induction ones. We don't
see
typically see them as much.
Yeah.
But like the vast majority of AC motors that you see are going to be in that squirrel cage category.
Yeah.
But you'll see different ones from around it. Synchronous. Induction motors are kind of
they're their own kind of category.
They're their own kind of category.
There are two common variants that you see. You have your polyphase induction motor, so that's going to be like your three-phase induction motor, and then you have your single-phase induction motor. And there are some characteristics between the two that we're going to dive into because they're the most common motors that you're going to run into.
Yeah. You're going to be working with a single phase this quarter, and you'll also be using a three-phase this quarter.
Yeah.
The vast majority of what we're going to deal with are those induction motors, which are asynchronous because they have slip in them. We'll talk about that. And then synchronous motors are very specific in their applications, and we don't really see them as much.
We don't see them as much. They are used primarily when this concept of slip that we'll detail like how slip works and what it means for the operation of a motor. But there are circumstances where slip is not acceptable in certain applications.
Yeah.
That's where synchronous motors come into play.
Yeah.
But most of that gets compensated for. So if we take a look at like the anatomy of a AC induction motor, you will see that it's very similar, like kind of overall theme to DC motors, which is what we looked at in a previous video.
Yeah. You've got a rotor, you've got a stator,
Stator.
you've got a shaft, you've got bearings, you got a fan.
Yeah, there's
Like-
a wiring box on this thing. It's like
What the heck's different than this? Is
Yeah.
it just what we plug the wires in? No, there's actually quite a bit of difference
Yeah.
as we get in.
the
dig a
fundamental
little
principle at play here is different. So
because an
we're dealing
induction
with AC.
motor is AC, and we're gonna take a break at this point. But this is just to remind you, AC is a sine wave. It's alternating, and so essentially, it's built around the fact that it's being generated by a rotation. So you
Yeah.
can tie that spinning generator on the right there to the actual formation of that sine wave down there on the bottom.
Yeah, and the thing that we will see is that this sine wave is going to be kind of directly tied to the behavior of the motors as we go deeper. But we're gonna pause here.
Yeah, we'll pause here.
Yeah.
Because what did we do? We just all of a sudden got back into trig,
Yeah,
which is something I swore I wouldn't do today.
I mean, yeah,
So, like, we're gonna chill for a second
We're gonna chill for a second,
and let you absorb that what we
Yeah.
talked about there with the broad overview.
and we will be back in the next video.
See you in the next video.